Hi, welcome back to LeetCode. In this we discuss LeetCode problem 1400 construct K Palindrome strings. So in the problem statement is that given a string S, an integer K, return true if you can use all the character in S to construct K Palindrome strings. Correct? K Palindrome strings or return false. So what is palindrome string first of all, right? Palindrome string is that the input string, and if you reverse the input string, then both are actually equal. Then actually we can say that this is actually a palindrome. So let's see some example. So this is the input example a. So if we reverse this string, the reverse string will be a. Both are actually equal, so that's why this we can say that this is palindrome. Okay. Next is ABA. And if we reverse this will be again ABA. So both are actually equal, so this is also a palindrome. Now next input string is ABCA. So if we reverse this, then what will be the input string? The reverse string will be ACBA. Both are actually equal. No, so this is not a palindrome. Got it? So a palindrome length can be odd, can be even. Right here actually this is odd, this is even. Right, both can be possible. Now what is the condition when it is even length? Even length means, so this is ABBA. So if we reverse this will be ABBA. Both are actually equal, so this is a palindrome. So frequency of A here is 2 and B here is 2. Okay. Next example is ABC CBA. If we again reverse this will be ABC CBA. Now the frequency of A is 2, B is 2, C is 2. Now here if we reverse this, the string will be BBBA. Both are actually equal? No. So that's why this is not palindrome. Okay. Now for the valid palindrome string for even length, now one thing actually you can observe that the frequency of each character is even. Here also frequency of A is 2. Here also the frequency of B is 2. For the next example, the frequency of A is 2, for B is 2, C is 2. Okay, this is actually the main point for the even length palindrome string, that the frequency of each character should be even. Correct? If the frequency of each character is even, then actually we can get the even length string. This is correct. Like how actually we can get a even length string? So if we add the frequency of each character is either all are actually even, then actually if we add this, then actually we can get only even. Else this will be odd plus odd, right? Then also we can get even. But for this situation, if we the frequency of each character is odd, then actually this is possible to palindrome. Let's see. Suppose the frequency of A is 3 and B is 3. The string length will be even. This is correct. But we have to check that for a palindrome, even palindrome string, what is this actually possible or not? So suppose A present thrice, so B will be suppose placed here. So if we reverse this, so this will be BA. Both are actually not equal. So that's why this is not a palindrome. You can take any example of this situation, like frequency of each character is odd, and this actually if we add all of this character, that will be getting the even length, but that is not a palindrome. You can see that example, all the example, you can take any example and validate that. Okay. So this is one possible, that the frequency of each character will be even for the even length. Correct. And for the odd length, what will be the condition? For odd length, this is odd length. This is actually palindrome. If we reverse this, so this is palindrome. The frequency of A here is 1. Now next ABA. If we reverse this ABA again, so both are actually equal. So this is a palindrome. This is also a odd length. So the frequency of A here is 2, B here is 1. Okay. So this is ABB. Okay, we can actually write this BAB. This is also possible. So if we reverse this, so we will get BAB again. So the frequency of A here is 1, B here is 2. Now one thing for this odd length palindrome string, you can actually observe that the at least means what? Only one character frequency is odd, only one character, and it must be, should be anything. So here actually you can say that the frequency of A is here actually on 1. For this next example, the frequency of B is 1, but else any other character will frequency will be even. Okay, for the third example also, the frequency of A here actually odd, but other it is getting even. How we are getting actually guide? So we have already proved that the even length, if we add even plus even, then we are getting even length, and this then actually it will be palindrome. Okay, so suppose this is actually even length, even. So this is even, then we are getting the even length, and this is also palindrome. Okay, now this should be odd length. So if I add plus 1, then it will be give the odd, the length of the input string will be then odd. Correct, plus 1 length. If we add one more character, then the length will be changed to an odd. Now then how actually I can place this odd character? This odd character how actually I can place? I can place here odd plus even plus even, then also we get odd, but this will be palindrome. No. Why? If we reverse this string, what will be the string? Even plus odd. So both are actually not equal, so we can't place this odd character at the front. Okay, this place is not possible. So what are the possible places? This place at the between and the end. So now let's explore in the middle position. So it will be even plus odd plus even, then also we get the odd length in a string. So now if we reverse this will be even plus odd plus even. So now you can check that both are actually equal. So we can place only one odd character at the middle. Now if there are two odd at the middle, this is possible to get a suppose 3 odd. 2 odd, if we add 2 odd, then actually this will be even length. Suppose 3 odd I have actually placed here. Even, odd 1, odd 2, odd 3. 3 different odd character, and now it is even. Now if we actually reverse this, then I will get it at the front even, then it will come at the second odd 3, then it will come odd 2, then it will come odd 1, and it will be at the end even. Now both are actually equal. No, this is actually equal, but this is not equal. This is equal, this is not equal, this is equal. So you can check that this is not a palindrome because at least one position it is not matching. So that's why I can say this is not valid palindrome. So that's why only one odd actually I can add into the string, palindrome string. Correct, and that position will be also the at the middle. Got it? Why actually I can also, this is clear that for the odd length in palindrome string we can take only one odd character. Correct. Now let's go to the, let's see some example that will be easy to build the algorithm or logic. So here actually the string is ABC and we want to generate 4 palindrome string. Is it possible? First of all we have to check that. Here actually 3 character is present, total 3 character, and when we want to generate 4 palindrome string. So if we assume that we have placed only one character in each palindromes in each string, so then at least how many character actually we need? We need actually 1 into 4 character at least we need. In each string we need only one character, at least one character. This is not possibly empty string, so that's why we need at least one character, and there are 4 palindrome string we want to generate, so that's why we need actually 4 character, at least 4. But we have actually only have 3 character, so that's why we have to return false here because we can't generate 4 string. Okay, now next is string is ABCD and we want to generate 4 palindrome string. Now this is the 4 empty string initially. Now the frequency of A is 1, B is 1, C is 1, D is 1. Now frequency of A is 1 means what? This is odd frequency. So odd can be placed only one string, correct? I've already explained. For the odd frequency, I can place in only one string. So suppose I have placed A here. Okay. Now next is B. This is again odd. Can I place B in this string? No. Why? Because I've already used one odd character here there. And if I again add one more odd character, there will be two odd character A, B. If I reverse this will be not a palindrome string. I have already explained why. Okay, so that's why I have to take a new empty string, or actually I have not placed any odd character yet. So this is actually empty. So I'll place this B here in the second string. Next is C. This is again odd. The number frequency is 1. Now, can I place C in this with A? No, because this I have already placed one odd there. With B, is it possible to place C there? No, because there is already one odd character. So I have to take a new string. So I will take new string, and third string I have placed C. Similarly for D, I will place a new string. So this is clear. So now we actually generated 4 palindrome string. Correct? All are actually odd length. So that's why I have to return true here. This is clear. How you are getting the output true for this situation. If you have any doubt, you can comment on that. Okay, I will definitely reply. Now, next example is A, B, C, D, A, and K is equal to 4. Now, the frequency of A here is 2, B here is 1, C here is 1, D here is 1. Okay, I have to generate 4 palindrome string. So the frequency of A is 2. So for the even frequency character, do I need to check anything? First of all, let's validate that. We don't need to check anything. So for the this is actually even. Okay. So suppose the frequency of x is suppose 4, and I want to generate 3 string. K is equal to 3. Like k is equal to 3 means k is equal to 5, but after placing all the odd character in the 2 string, now we have still 3 empty string. So what we actually have 4 character of x. Can actually generate this 3 string of palindrome? Yes. How? Suppose x I have placed 2x here, 1x here, 1x here. Correct? Wait. Okay. Total character frequency is 4. This is fine. And all are actually palindrome. How? This is palindrome. If I reverse this, both will be xx again. This is actually palindrome. If the length is 1, that will be always palindrome. This is also palindrome. Okay. Now I want to generate, suppose x is equal to 4, and I want to generate 4 empty string, 4 palindrome string. So I will place all x here. This is possible. Now I want to generate x is equal to 4. I want to generate 2 string. Okay. So I'll place 2x here, 2x here. Okay. Now I want to generate only one string. So I'll place all x here. Got it? This is also palindrome. Got it? But is it possible to generate 5 palindrome? No. Because I can place only 4 in 4 different string. This will be one string will be still empty. So that will be always already handled in the at the front, that the length of the string should be always greater than equals to the k, the string k palindrome string that we want to generate. So the total length will be always handled. Got it? So that's why this is clear that for the even frequency character we don't need to check anything, because this is sure that this will be always possible to generate palindrome string. Correct? Now for the odd, what I have to do? So for even I will skip this. I will go to the next. So b is equal to 1. So this is actually odd character, odd frequency. So I will take one empty string or actually placed b there. Correct? Now next is c. Again this is odd. So I will take another new empty string or I will place c there. Now this is d. So I will take one empty string and placed d there. Right? Now still we actually want remaining one empty string. That is correct. Now I placed already B C D. Now this is A is equal to 2. Still we have actually present because we have to not consider. But do I need to check anything? No, because from A is equal to 2, I want to generate one palindrome string. So this is possible. I will place 2A in this string. This is clear. So that's why what I have to consider. Initially we will have 4. Suppose next example is that that will be easy to understand. A, B, C, D, E and K is equal to 4. So initially we will have 4 empty string. Okay, and the frequency of A here is 1, B here is 1, C 1, D 1, E 1. Now first of all I will iterate this. So frequency of A is 1, so I'll take one empty string and place A there. Next is again B, so this is odd, so I'll place B there. Next is C, I will place C in the third string. D, I will place D in the fourth string. Now we will have still one odd frequency character. Can actually generate 4 palindrome string? No, because there is no empty string possible after D. So if I want to place E there, I will add E here or here or here or here. So this is possible that none of this actual string will generate a palindrome. So that's why I have to return false here. That if there is no empty string, that actually you have not placed any odd character there. If there is no empty string, so that time I have to return false. This is clear. So what we'll do, first of all, the example and the algorithm is algorithm means the how we are getting the output. This is correct. This is clear. If it is clear, then actually first I will say that first try to code yourself, then actually come to this algorithm and the code section. That will be good for you. So first of all, what I have to do? First of all, I will count the frequency of the characters present in the input string S. Correct? So then I will have the how many A are present, how many B are present, how many Z are present in this way. Now what I'll do, I'll iterate that character, how many present, frequency map. So if the frequency of current character that we are iterating, if it is odd, that means what? I have to take empty string that I will place one single odd character, that's empty string. Correct? So if there is no empty string present, that time return false. Else I will consume that empty string, and the next time I'll go to the next character in this way. At the end, if we able to place all the character odd character especially correct with a new empty string, so at the end I return true, because for the even we don't need to check anything, because I have already shown that how actually we can generate all the possible number of palindrome string we can generate from an even length character. Correct? So that's why return true at the end. So now go to the code. So first of all, if our input string length is less than k, like the input string length is 3 and the k is 4, so we can't generate this 4 palindrome string, so that's why return false. Next is we have to count the frequency of each character. So here actually 256 characters can be present. So I have taken a vector of frequency and the size is 256. Initially the frequency is 0. I have initially 0. Now I'm iterating the input string S, and for each character I am increasing the frequency by 1. Got it? For particular character. Okay, so after this for loop, I will have the frequency of each character present in the input string S. Right? Now I am iterating the frequency vector again. So now what are you doing? I will check that okay, how many A are present. Okay, so that's why I check the current frequency is odd or even. So if it is odd means what? How actually I'm doing this? So odd means at the end, the binary represent at the end. Suppose this is 3, frequency is 3. So what is the binary representation? 1 1. And if I do end of 1, so I'll get what? This 1 will give 1, and these all are actually at the left side it will give 0, correct? So ultimately the binary decimal value will be 1. So that's why if I take the AND value of with 1 with the frequency value, if it is, that means this is odd. If this is true, that means the frequency of the current character is odd. So I'll consume one empty string. So initially the empty string will be 4. 4 means the k empty string will be initially present at the initial. If k less than 0, after consuming one empty string, if the frequency or if the remaining number of empty string is less than 0, that means what? There is no more empty string. So that time return false. Else if it is k greater than equals to 0, that means we have consumed one empty string that actually available that time. If it is less than 0, that means that is actually not available. We have already consumed all the available empty string, correct? So that time return false. And at the end, if we are able to place all the odd character correctly in a new empty string, so at the end return true. This is clear. We can generate all the possible substring for even length. That's why we are not considering anything for the even length. Got it? So if you have any doubt, any suggestion, you can comment on that. And this explanation is clear for you. And if you understood correctly, please like the video. If you not yet subscribed, please subscribe the channel. Please. Now what is time complexity of this? Time complexity. So first of all, here actually we have taken one for loop that actually iterating the input string. So the input string length is suppose n. So that time for this time complexity for this for loop will be big of n. If there is n characters present in the input string s. Now we are iterating another for loop that is iterating the frequency vector. So the frequency vector is size is 256. So this is a constant. Correct? So ultimately the total time complexity will be big of n, because n plus 256 it will be actually ultimately big of n. So time complexity is clear. Now what is the space complexity? Space complexity is we have taken a vector of 256. Any other things? No. So the space complexity 256. So this is again constant. So this will be big of 1. This is clear. What is the time complexity and space complexity? Okay. So I've shared this code link in the description. If you want to follow, you can actually follow that. Thank you.